But anyway, so hi everyone. So I spoke in AI Thinkers last year in June in Amsterdam, and in July I also spoke in San Francisco. And I talked about deep research back then. Kind of mixed, opinions. Some people were like, I just want like fast, short answer, and other people were impressed. Of course, 5 months later, Google released deep research, and then everybody started talking about it. So that's just to say that I'm going to now show you the next big thing. And I'm just partially joking because actually I was listening to the OpenAI Dev Day the other day, and they were actually presenting a simpler, more primitive version of this. But they also mentioned the technique I'm going to talk about, so I think they are onto it. So has anyone built a deep research agent before? Okay, one person. So so how does it work? So you have a query, right, from the user, and then you have some sort of agent that is going to create a plan and then fire up or like delegate the task to different sub-agents that are going to be tasked to extracting information that is relevant for this. And this could be like different angles of the question, right? Then you want to feed this into these information mergers, which are going to take the document hits, and then I'm going to create some sort of snippets of knowledge about the question. And then you kind of come back to the main agent and provide this back to it, and then it will kind of reason whether it needs more iterations or if it's enough. So you will go in a loop, right? So you can do like 2 or 5 or 10 loops like this, depending on how good the initial queries were. And in the end, it will decide like, okay, this is enough. I'm going to write the report, and then there's another agent that will just generate the final answer based on these snippets. So the question is, how do you make this really good, right? So all of these, maybe let me just clarify this. So all of these kind of robots here have a prompt. So you can imagine that here you have 4 of them, and then you need to refine each of the prompts until it's good. But that takes a lot of time, right? So we worked, I mentioned it, I presented like in June, and it took a few months of like actual development work to make it very good. So there's a TLDR of the technique. Basically, you have some sort of question again. Maybe this is like a benchmark. You pass it to this multi-agent system. So this talk is not about deep research in particular, but the research is one of these multi-agent systems that are very popular right now, but it will work for any multi-agent system. You generate the output of this, right? So this is going to be the report. And then you want to have some sort of feedback on the output. Once you get the feedback on the output, you can pass it to some optimizer, which is another prompt, to criticize the report, and then create another kind of set of prompts to generate new agents. You pass that into some agent pool, and then finally you have some sort of selection to create the next best agent that you can try, and then go into this loop. So all of these things that you see on the right are trivial, right? This is just AI slop, right? It's like LLM created this, pass it to another LLM that created that, pass it to another LLM that created that, right? So this is just complete hallucinations. And actually, the secret sauce is in this agent selection part. So the first paper is called TextGrad. And basically, what they trying to do is it's like an analogous of like gradient descent, right? So we want to find the changes to these sub-prompts that make the biggest impact in the quality of the answers, and then try to keep changing that until you converge to something. If you kind of plot how this evolution looks like, is something like this, right? So it will kind of iterate a little bit until it finds something, and then it will just keep trying to modify that prompt. So maybe it's not clear here what it means, right? But each of these blobs is a prompt, or like a sub-agent, or like sub-prompt, right? So it's saying identify one of them, and it just keeps iterating on this one. The problem there is that you might be on like a local minimum, right? So it might not be the best solution. And then there's another paper, which is what I heard in this podcast, but we have been working on this for longer, which is called GEPA. So GEPA means genetic Pareto. So here, as I mentioned before, the kind of secret sauce is the engine selection. So what they try to do is that you change the sub prompts, and then you can make mutations, right? So the mutations means like maybe you have two agents and you combine them in a way that you select the best prompt, the sub prompt of each into a new, complete new one. And then you have some sort of Pareto optimization process that will give you, let's say, the best agent. And if you now plot the kind of agent evolution through this, it looks more like that, right? So it doesn't really focus on one aspect, but it explores the different areas. So this is just to say that you can make progress on optimizing agents without actually you manually writing the prompts. And it's kind of strange, right? Because these are just LLMs doing it on its own. So how does that work? Well, we just plot the solution, right? So we just created the results. So here I show you the results that we found. So this is based on a benchmark. So it's called a QACS. So they have two starting points. So we started with a minimal prompt for each sub-agent. And the minimal prompt is this kind of light blue bar on the left. And I think the prompt was very simple, like something like answer the following question. But that doesn't make sense on deep research, right? Because all of these sub-agents have different tasks. So then we have the human optimize, which is the light orange. So that's our best deep research set of prompts. And then we use a 4.1 mini because that was kind of fast. And then we also, just for fun, threw the OpenAI prompt optimizer version, which is the gray bar on the right. So you can see that in general, like TextGrad is not that good. So JEPA is a little bit better, but the point here is that you can reach a higher, so maybe I didn't explain it properly, but the dark blue one is like the optimized version of the light blue, and then the dark orange is the optimized version of the light orange, right? So you can see that in the JEPA case, you started with a very low quality, but then it went even higher than the orange case. So I guess that's to say that the way you start with the prompts can change how you end up. And of course, the gap between the human expert created prompts is not as large because, as I said, we already spent like months on it. So it's maybe good to that we were already kind of close to the best. So JEPA seems to be better, and is what also these guys mentioned. So of course here we have a benchmark, right? But if you try to do it in reality, you don't have a benchmark. So in reality, it means like you are creating some agent for maybe your company, and then you have a bunch of documents, right? But then how do you create this benchmark? So this is kind of the next step that we're exploring now. So this will be a different talk, but we have this kind of open source tool called Ragilo, which is used for evaluation of agents. And this uses this kind of pairwise evaluation and some ELO, like chess-like tournaments. And so the idea here that we want to do is that instead of having a rubric or like a golden answers, we want the agents to actually evaluate themselves into a complete cycle, and then try to co-evolve the evaluator's prompt so that both systems kind of evolve into the right answer. So this is still like pretty much work in progress, but I think this is also what other companies are trying to achieve. So we'll see what happens in the end. So that also I wanted to share with you. So you can add me on LinkedIn. And I also run this other meetup in Amsterdam called Open Search Meetup. I mean, to be honest, we all talk about agents anyway these days, so it's going to be pretty similar to this one. Thank you.
Thank you for a great talk. Questions? Two questions.
Hi, thanks for the talk again. So I wanted to ask you, can you go to the previous slide once more? Yeah, so in this pairwise gradient generator, you explained a chess-like tournament, right? You're generating ELOs So what is the actual gradient that's being generated? Because if you're trying to judge what exactly changed so you can take a step in the right direction, how are you measuring this change?
So, so when you have, maybe it's good to explain what happens when you have a rubric. So when you have a rubric, it's like having a golden answer, and then the LLM evaluator is just saying, is the LLM created one as good as the human created one? And then that's how you kind of quantify, and that's you assign a number, and that's how the other plots that I show you that, how it evolves. But if you don't have this golden answer, then you need another way of doing that. And the way we figure out by just empirical evidence is that if you have an LLM compared to answers, it's going to be pretty good. So that signal kind of correlates well with the human experts. So by using this procedure, you can kind of find the best agents out of a bunch of pool of agents just by using LLMs without any golden answer. So that's kind of more like an empirical evidence that we have.
So if it's golden answers, then it's more like a similarity which is closer to that golden answer. Otherwise, it's just LLM as a judge.
Exactly.
Okay.
Thanks.
Hello. If you go back to your graphs, so these ones, so how close, we can see how they are in comparison to each other, but how close are they to perfection? So for example, you see that the blue one and the orange, the dark blue, dark orange are better than the light blue and light orange, but are they any good?
Yeah, that's a good point. So, in the end, again, this is just a benchmark, right? So it's like you can optimize this for months to play the benchmark game, which is what most companies do these days anyway. So, but for us, this is a signal of how good something could be. And then, of course, you want to actually try it in practice with real people that are using this for their job or whatever they need to do. So the light orange one is pretty good. So it's like comparable to, let's say, ChatGPT, or even a bit better, because ChatGPT can be a bit, talks too much. But that's pretty good, right? So the improvement is not as large. And then the other thing that you can think about is like, well, what if the architecture is not the right one, right? So the first talk that mentioned orchestrator versus non-orchestrator, right? Maybe the architecture can be changed as well. And that will lead you to the next jump in performance. So I guess, yeah, it has to do with, you actually need to try it in the end. But this is just a benchmark.
Yeah. Thanks for the talk. I'm wondering, so now you're going kind of all in on evals. You are generating this perfect prompt to satisfy the benchmark. Aren't you worried that you're going to lose touch with the vibes, that you lose this feeling of how to write a good prompt, and that eventually your product is just something that has been generated by AI, but it's not really you that put that in there, right? Your knowledge.
Yeah, absolutely. So as I said, this is just like the test of the technique, but I didn't mention what I do, and it doesn't matter, you can ask me later, but we basically try to make things work for actual humans. So we are really concerned about making it practical, and this is just like the study of the techniques to select which one we will actually try with in real use cases.
Thanks.
Yeah, back on the pairwise comparison. So in the idea being is because you do not have a ground truth, you cannot say something about the absolute score of one example, but you can say one is better than the other. So if I do that often enough, I get to the best result. But you could change different things in the prompt, right? So for example, let's say maybe one gets dynamic few shot examples, others get like memory compaction. I don't know. Like how do you correctly evaluate if the change that you did to the prompt was the reason why it increased the ELO score?
Right. So maybe I should have talked about RAG-ELO maybe next time. So that's a really good question, right? So the point here is that the prompt of the pairwise evaluator is also prompt, right? So you can tweak that. And there's another kind of secret sauce there, which is you need to tweak it in a way that reflects the human expert's desires of what it makes a good answer. But the point that we are trying to make in this last slide is that we want to actually try to evolve both this prompt of the evaluator and the prompt of the multi-agent in parallel, so that they can both feed each other from some other source.
Okay. Could you maybe go back to the slide before? Could you maybe say a bit more about how robust these results are? So if you run this 100 times, how often do you actually get it better? Are there sometimes that actually get worse than before? Does it get totally lost?
Yeah, absolutely. So I think this one was run just a few times, but you're right that, I mean, no one these days puts error bars, but there is some sort of error bar here. So I would say like most of like the blue, all of the ones on the top, they're probably very similar. And the other question is maybe what was mentioned before is that what do these numbers mean, right? So is 0.001 like a lot better? Probably not, right? So at the end, you need to actually check it with an expert and see which one is better.
Probably, yeah. That's
Happy
it.
to answer more questions later.
I see there are more questions, but actually you can ask it during the networking.
Like
part.
all benchmarks are wrong, but some are useful, right?
Exactly. Thank you for a nice talk.